16th question, same, construct minimal DFA that accepts all the strings of A's and B's, where each string start and ends with same symbol. So first understand the question. He said that that string must start and ending with the same symbol. For example, if you take one symbol A. Now the question is it a starting symbol? What is the starting symbol? A. And what is ending symbol? A. So is this acceptable for us? Means yes, acceptable for this 16th question. Starting symbol and ending symbol should be same. And like this, B is also accepted. Means starting symbol and ending symbols also same. Now, is this accepted for us? Means yes, starting symbol is A, ending symbol is A. In between any number of A's and B's comes, there is no restriction on this one. Starting symbol and ending symbol should be there like this. Is this accepted? Means yes, starting symbol is B, ending symbol is B. In between any number of A's and B's come, there is no restriction on this one. So like this, starting and ending symbols are true. So what are the possibilities? Means epsilon also contains starting symbol and ending symbol is same. And single A is also starting symbol and ending symbol is same. Single B is also starting symbol, ending symbol is same. Then we know that one, starting with A, ending with A, in between any number of A's and any number of B's, okay for us. And B, in between any number of A's and any number of B's, okay for us. Like this, you will get some possibilities, 5 possibilities like this. So it is also easy one, we can construct DFA for this one. So initially epsilon is okay for us, single A is accepted for us, single B is accepted for us, and after that AA like this BB, in between any number of A's and any number of B's, any number of A's and any number of B's. These are the 5 possibilities we have. So initially epsilon is means what? Starting state and final state is same. That's for epsilon. And for single A, like this, for single A, it is also accepted for us. And for single B, this is also accepted for us. Alright. So for single A is also accepted, single B is also accepted. Then afterwards, if starting symbol is A, then ending symbol should be also A. In between any number of A's and B's come okay for us. Alright. Now, so like this, if single B comes like this, any problem for us, there is no restriction. If single B comes, then after on S4 if you apply A, it always ends with same symbol A1. But in between on S4 if you give any number of B's, okay, there is no restriction on this one. On S2, any number of A's come, any restriction on this one, there is no restriction. Like this, this is for start with A and ends with A. Start with A and ends with A. And coming to this one, on S1, if I apply B, it ends with, it goes to S3. And on S3, if any number of B's come, there is no restriction. It always ends with B only. B like this, any number of B's will come. If on S3, if single A comes, then on S4, any number of A's come, and on S5, if we apply B, it always leads to final states. B, A, any number of A, B. So if you consider this one, it always starts with B and ends with B only. And above case, it starts with A and ends with A1. Like this, you will contain how many states? Means it will contain 5 states. So this is important one. This is the previous year question in the GATE examination and academics also. So this is the 16th question. Now coming to 17th question. 17th question, similar to that one, but he asked that construct minimal DFA that accepts all the strings of A's and B's. But starting and ending symbols are different. Starting and ending symbols are different. That's the question he asked. 17th question is same, but in the previous question, starting and ending symbols are same, but here starting and ending symbols should be different. So this meaning is that if the string is start with A, then it should end with B. In between, any number of A's and B's come, there is no restriction. And if the symbol starts with B, it should ends with A. In between, any number of A's and B's come, there is no restriction. That's the question he asked for 17th one. So this is also easy one. See, state S1 and state S2, state S3. So if single starts with A, then it should ends with what? B. Am I right? If it starts with A, then it should ends with B. And on S2, if any number of A's come, any restriction means there is no restriction. And on S3, if any number of B's come, any restriction means there is no restriction. Any number of B's may come. And on S3, if single A come, it always reaches to S2, like this, A, B, A, B, A, B, A, B, like this. Any number of A's come. And coming to, if you apply small b and S2, if you apply small b and S1, it reaches to S3 state. And on S3, if you apply small a, it always reaches to S5 state, like this, which is a final state. And at the end, if any number of A's come, there is no restriction. And on S4, if any number of B's come, there is no restriction. And if single B comes like this, it is S4 like this, it will be repeated. So this is the example for starting and ending symbols are different. It is also contains how many states means 5 states. Now coming to 18th question. Construct minimal DFA for the language L is equal to A power M, B power N, where M comma N greater than or equal to 1. This meaning is that given language is L is equal to A power M, B power N, where M comma N greater than or equal to 1. This meaning is that language is given A power M, B power N, but M should greater than or equal to 1, N should greater than or equal to 1. Now can you tell me, if you take M is equal to 1, N is equal to 1, what is the minimum of string means? A power 1, B power 1, that is equal to A. Am I right? If I take M is equal to 2, N is equal to 1 case, then you will get the string A single B. Am I right? Why means M is equal to 2 means A square, N is equal to 1 means B power 1. WB you will get. Now, if M is equal to 1, N is equal to 2 case, this case you will get the string of A double B. Like this you have to form the strings. So this for this one, what is the minimum length string means? For this language, minimum length string is AB. Then after any number of A's come, okay, followed by any number of B's. So initially any number of A's come, then after any number of B's come. So like this, for this language we will construct easy one, S1 on S1, S2, S3. So single A, single B is accepted for us, and at the end any number of B's come, there is no restriction. Am I right? At the end, N is greater than or equal to 1 means any number of infinite number of B's come, there is no restriction. And on S2, any number of A's come, there is no restriction. On S2, any number of A's come, there is no restriction. And the last one, if on S1 if single B comes, this always leads to dead state. And on S3, if single A comes, it always leads to dead state. Why means it always ends with B only. If at the end if A comes, that means invalid state. And on S1 if single B comes, it always leads to dead state. This is the question answer for the 18th question, where L is equal to A power M, B power N, m greater than or equal to 1. These are all the previous gate questions and academic questions. That's why I'm explaining briefly. Now, coming to 19th question. 19th question. Construct minimal DFA for the language L is equal to a power m, b power n, where m, n greater than or equal to 0. Little bit different is there. Given language is same, a power m, b power n, but m, n greater than or equal to 0. This meaning is that m should be greater than or equal to 0, n should be greater than or equal to 0. So, if you take the possibility of m is equal to 0, n is equal to 0, then what is the minimal length string means? A power 0, b power 0 always leads to what? Epsilon. Nothing is there. And if m is equal to 1, n is equal to 0, what is the minimal length string for this one means? A power 1, b power 0. That's called A only. And second case, if you take m is equal to 0, n is equal to 1, for this case, you will get a power 0, b power 1, that is equal to b1. And next case, m is equal to 1, n is equal to 1, then you will get a Williams string. That's possibilities you have to form a power m, b power n, m, n greater than or equal to 0. So, minimum length is epsilon means like this initial state itself, starting state, and next onwards, pass lo consider n. So minimum length string is epsilon means starting state itself, final states, and on S1 there is no restriction on number of A's. Infinite number of A's may come, there is no restriction. Why means m greater than or equal to 0 no? Means 0, 1, 2, 3, so on, infinite number of A's come, there is no restriction. So infinite number of A's come. And if single B comes like this, then after that, any number of B's come, there is no restriction. So, it should starts with number of A's, then ends with any number of B's. So, initially, there is no restriction on number of A's, but after that, one single B comes, then it always ends with B's only. That's the language they given. But after number of B's, if small a comes, this always leads to which state means dead state. That's the answer for this 19th question. So L is equal to a power m, b power n, where m, n greater than or equal to 0. This always contains how many states means 3 states. And coming to 20th question, similar to like that only, but language given is a power l, b power n, and c power n. This is also easy one, similar to like that only, but he gave restrictions on L, n should be what? Greater than or equal to 1. This meaning is that L should be greater than or equal to 1, M should be greater than or equal to 1, N should be greater than or equal to 1. He gave the restriction. So, similar to like that only, initial state is S1. Next, it always contains minimum A, and it always contains minimum B, and it always contains minimum C. Like this. And after that, any number of A's come on S2, any restriction? There is no restriction. On S3, any number of B's come, any restriction? There is no restriction. At the end, any number of C's come, there is no restriction. For this one, Y means L should be greater than or equal to 1, M should be greater than or equal to 1, N should be greater than or equal to 1 for the language A power L, B power M, C power N. So, single A should be there, single B should be there, single C should be there. In between, on S2 any number of A's come, okay. On S3 any number of B's, okay. On S4 any number of C's, okay. But on S0, if B comes, it always leads to dead state. Y means always starts with A1. Minimum length is 1, so always leads to dead state. And if C comes also, that also leads to dead state. And on S2, if C comes, that's also dead state. On S3, if A comes, that leads to dead state. and on S4, if A comma B comes, that will lead to dead state. So this is the answer for 20th question. So these are the questions are very important for the academics and for gate syllabus also. They will ask the questions that how many states are contains. For this language A power L, B power N, C power N means it will always contains 5 states. Coming to 21 question, same language they gave A power L, B power N, C power N, but they gave restriction that L comma N should greater than or equal to 0. This meaning is that L should greater than or equal to 0, M should greater than or equal to 0, N should greater than or equal to 0. So all 0 means you will get minimum string of epsilon. Then after what? Single unstring, double unstring, triple unstring, like this you will, so many you will get. So minimum is epsilon means starting state itself is final states. And in the starting state, you will get any number of A's, there is no restriction. And on S1, if you give single B, then there is no restriction, but it always ends with any number of B's. And on S1, if you give small c, this is also valid, and any number of c's comes, there is no restriction. And on S2, if you give input c, this is also okay for us, this is also ends with c. And coming to on S3, if A comma B comes, this will always leads to dead state. Why means if after the C, after the n number of C's, there is no A and B comes. So it always leads to dead state. And on S2, if A comes, this also leads to dead state because after the B, A should not come. That's the sequence they give. A power L, B power N, C power N. So this is also contains how many states means this always contains 4 states. Now coming to 22 second question, same the given language is L is equal to, for 22 question, L is equal to A power N, B power N. He gave that N should greater than or equal to 1. And you can form the strings that number of A's should be equal, then after number of B's should be equal. Means this is valid one A, one B. Double A, double B. This is also valid for N is equal to 2. For N is equal to 3, like this is valid. A, B, B. Triple A, triple B. And 4 A's, 4 B's. Like this, for this N is equal to 4, this is valid. Now, what is not possible means, this is not possible. Am I right? Reverse is not, but number of A's should be followed by number of B's, like this. Number of A's should be followed by number of B's. So equal number of A's and equal number of B's. This is the question they gave. For this question, DFA construction is not possible because this is not a regular language. For this one, DFA construction is not possible. So why means this is not a regular language. This is not a regular language. For this one, we can construct push down automata. Coming to next unit, I will explain why we can't form means you need extra one stack required for this one. That's why we can't construct DFA for this one. I will explain this example during the push down automata examples. Okay, now comes to next one, 23 question. Construct minimal DFA that accepts all the strings of A's and B's, in which number of A's and B's are should be even. Means this one is directly I am giving like this. Zero number of A's and B's okay for us, and like this even number of A's is accepted for us, and like this also accepted number of B's is even. And coming to this one, this will also accepted like this. This is the answer for 23 question where number of A's and B's may be equal. So I am explaining briefly, very example, very neatly. So This theory of computation, this subject, it will be useful for your GATE examinations and academic syllabus also. So please subscribe to my channel and like my videos. Thank you.